Hey guys, welcome to your Unit 7 Lesson 2 notes on polynomials. By the end of the day, you'll be able to identify and classify polynomials and find their degree. So first, we're going to identify polynomials. So the first thing we're going to do is, before we talk about a polynomial, let's talk about a monomial. So maybe I should spell it right. Monomial. So here, nomial means number, and mono means one. So a monomial is something that has one number. It's a number, or it's a variable, or it's a product of numbers, product of numbers and variables that have only positive, non-variable exponents. That's kind of a lot of information. I'm just going to show you a bunch of examples and say, this is a monomial, this is not. Okay. So this -4 is a monomial because it's a number. So yay, this is a monomial because it's a number. Y is a variable. It's just one thing. When you think monomial, think one thing. It's a variable. Variables represent numbers. A squared is a monomial because there's just one guy there. It's a times a, but you can combine those to get a squared. So that is a product of variables. And then this 1/2 x squared y is a product of variables and a number 1/2. So this is a product of numbers and variables. So yes, these are monomials because they are one thing. They're one term, we say. It is numbers, variables, or them multiplied together. Now, this is direct contrast with 2 to the xth power. When you have x as an exponent, it's not a monomial. It just gets way too complicated. So no, this is not a monomial because the exponent is a variable. And x squared plus 3, this is not a monomial because it has this plus here. So we consider this a sum of 2 monomials. X squared is a monomial, 3 is a monomial, and you can multiply them together, that's fine. But when you add them together, then it becomes a binomial because there's 2 of them. Here, 5a to the negative, it's a negative exponent. We're not allowed to have those. That's not simplified. So because this exponent is negative, that disqualifies him from being a monomial. And then finally, we have x in the denominator. This is the same kind of idea. Well, this is the same idea as this guy, right? 5a to the 2nd power is 5 over a squared. You can't have a quotient be a monomial. Can't have this dividey guy down here. You can have a product. Can't have a quotient. Cool. So when you think monomial, think one number, one term. So look at this. Look at this. Is this a monomial or is it not? Number 1, yes, is a monomial. It's a product. Great. Number 2 is not a monomial, because it's a sum. In this case, it's a difference. Number 3 is a monomial. It is one number. It's one thing. It's a weird check mark. And then finally, x squared is another monomial. It is just one term. So when you have a monomial, then you add a bunch of these terms together, we call that a polynomial. Poly meaning many, like polygon or polyester, or polynomial, like this. So still yellow. Still nomial still means numbers, but this time poly means many. There are a bunch of them together. The key here is that you add them all up. You add them together, or you minus them, but that's just like adding a negative, okay? Now, when we look at this guy right here, In order to figure out how many terms you have, you just look at how many plus, you look at your plus signs. Right? So we say that this guy has, let's count them, 1, 2, 3, 4 terms. This polynomial has 4 terms. We have specific, and the terms are, sorry, I did not list the terms, x cubed, x squared, 7x, and 9. Now we say that the term is each monomial in the sequence, okay? Now a binomial, just like bicycle, all binomials will have 2 terms. Here we've got x and 2, 5c and negative 4, 5c and negative 4, and 4w squared and negative w. So split them all with your plus signs. And then a trinomial, just like a tricycle has 3 wheels, a trinomial has 3 terms. So you got a plus b and c, x squared plus 5x plus negative 7, 3a squared, 5ab, and 2b squared. So the terms are the things that are separated. The terms are monomials separated by pluses or minuses. So let's determine, is this a monomial, a binomial, or a trinomial? Quick reminder, a monomial has 1 term. A binomial has 2 terms. A trinomial has 3 terms. Excellent. Okay, so here we've got 1, 2 terms. Here we've got, this looks like a binomial, right? But it is not. 5a minus a simplifies to 4a. So this is actually has just 1 term. Oh, we need to actually say it. My bad. So this is a binomial. This is a monomial. This has a quotient in it, so it's not actually any of these. And finally, x squared minus x plus 2 looks like it should be a trinomial, right? Because it's got 3 terms. But guess what? Negative 6 plus 2 is the same thing as negative 4. So this is really x squared minus 4, which is a binomial. So we have classified polynomials in one way already. We've classified them by the number of terms they have. You can also classify them by their degree, not like master's degree or a doctorate or something. But the degree of the polynomial is the highest exponent on top of a variable. So here in this guy, we've got a hidden little exponent of 1. So we say this is a first degree polynomial, or a polynomial of degree 1. Here, the highest polynomial is 2. So we say this is a second degree polynomial, or a polynomial with degree 2. This guy right here, you'd think it's 3, right? Because that's the first one, but guess what? 6 is actually the highest one. So we say that this is a polynomial of 6th degree, or a polynomial with degree 6. Isn't that great? Cool. By the way, if you ever have 2 variables added to, like, multiplied together, so if you had like x squared y to the 5th plus, 3 or whatever, you would add the variable exponents together, and this would be a polynomial of degree 7. Fun fact. Okay, so what is the degree of this polynomial? Well, look for the highest exponent. The highest exponent is 2, so this is a polynomial of degree 2. What about this guy? Well, to find the degree of a polynomial, look for the highest exponent. The highest exponent is 5, so this is a polynomial of degree 5. Now sometimes it's easier to find the degree when we have the highest exponent out in front, and in fact that's the convention that we want to follow. We always want to have the powers of x in descending order. So start with the biggest and go to the smallest. And that's how to get a correct answer, is your exponents need to go from biggest to smallest. So if you give me an answer like this, that will not get full credit. You need to look at the exponents and write them in order. So that's the same thing as 5a squared plus 7. Like this. And our next guy, we need to put them in order. So we'll look at, very important step. Whenever you have subtractions, change them into plus and negative, because the term itself is negative 4/5, negative 3, 6x squared. So they need to take their negatives with them. So it gives us a negative 4x to the 5th power plus 6x squared plus a negative 3. Notice how they all took their negatives with them. And then once you do that, then you can change your pluses to minuses if you want to. In this case, the only thing that would change is changing the plus 3 at the plus and negative 3 at the end to a minus 3. But that's something super important to remember. Oh, dearest, what happened here? That happened there. Okay, make sure you're writing them as plus negative, because they take their signs with them. They're like their carry-on luggage that needs to go with them. All right? Okay. So here we've got a park in Virginia. It's Manassas National Battlefield Park with an area of 5,067 acres. We're writing this in base 10 by separating these guys as powers of 10. For example, when you look at 256, that's 2 times 100, which is 10 squared, plus 5 times 10, which is 10, so 5 times 10 is 50, plus 6 times 10 to the 0th power, which is 6 times 1. We're going to do the same thing with 5,067. Okay. So let's take each of these guys and write them as their own separate little power of 10. So we have 5, 0, 6, 7. 50, 67 means we have 5 thousands, we have 0 hundreds, we have 6 tens, and we have 7 ones. And we add them all together, which gives us 5 times 1,000, which is 10 cubed, plus 0 times 100, which is 10 squared, plus 6 times 10 to the 1st power, plus 7 times 10 to the 0th power. So 5067 is equal to 5 10 cubed plus 0 10 squareds plus 6 tens plus 7 tens to the 0th power, 7 ones. Okay, so same thing. We've got 5 thousands, no hundreds, 6 tens, 7 ones. Is that fun? So this guy has 4 terms. Count them. 1, 2, 3, 4. Okay, so when you're looking at a polynomial, you can rank it by the degree, which is the exponents, by its number of terms, which is the number of things that you add together, number of monomials you add together, and a monomial can be considered one number. Okay, have a great time on your homework.